All right, good morning. So welcome back to Intro to Statistics here. So problem number 4, we're talking about normal distribution. Okay, so always makes a good quiz question because again, it's got medical data in it, so that's always a good choice for me. It's got high blood pressure, so that's always a topic near and dear to my heart. So in a recent study, we have the CDC has reported that diastolic blood pressures of adult women in the United States is normally distributed with a mean of 80.8. Okay, I wish, and a standard deviation of 10.2. Okay, so round your answers to 4 decimal places. What proportion? Okay, what proportion of women have blood pressures lower than 69 milligrams of mercury? 80 milligrams Hg. That's the atomic symbol for mercury. So that's how they're measuring this. Okay, and that's okay. So trust that. So what's going to happen here is we have X is our normal distribution. Okay, and then what are we doing here? We're having this going to 80.8. Okay, and our standard deviation looks like was 10.2. Okay, even though these are not the most pretty numbers, the calculator is going to handle the heavy lifting on this, so we don't really have to worry too much about the fact that these are a little ugly. Okay, so what is the proportion of women who have blood pressures lower than 69? Okay, so what we're going to do is, here's our 80.8. We're taking steps of 10. Okay, and they want to know lower than 69 is a number smaller than 80, so we'll put it here. And then we want this area here. We want this area in here. Okay, so we need a number that is smaller than 80.8. Okay, in steps of 10, what is a number that is relatively small to this? So we're going to get a norm CDF, right? We want low, high, mean, standard deviation. Okay, so I urge you practice with these things because you're going to have to be able to do this on your own as well. Okay, so norm CDF, low, high, mean, standard deviation. Okay, so after being in the hospital for the blood pressure, I have it on good authority that you need a blood pressure of at least 0 to be alive. Okay, so that's an important thing. And then the high number they want is, right, it's not all the way up to the mean. They just want lower than they want 69. Okay, so 0 to 69. Okay, and our mean is 80.8, and the standard deviation was 10.2, and that's what we're going to type in the calculator. Okay, so we're going to go back here. We're going to go say this guy right here, and we're going to go with, I wonder if it's on that. Okay, second function. This, no, we want second function distribution norm CDF. Okay, we're just going to type in a 0. Okay, 69. Okay, and then our mean is 80.8. Okay, 80.8. And our standard deviation, 10.2. How about we actually get the 10.2? Okay, and then we'll enter that. Now we got 0.1236. So we're going to say 0.1234 because, well, how many decimal places do they want? 4 decimal places. Okay, so we're going to say 1, 2, 3, 4. This 6 is going to turn this one into a 7. So 0.1237. So 0.1237. Okay, and that's what we're going to type in. Okay. 0.1237. We'll check. Right. Okay, what is the proportion of women who have blood pressures between 70 and 90? Okay, so again, this seems to be a really hard problem. For the calculators, it's actually not. This is one thing I will appreciate the calculators for, because we had to look this thing up and subtract things. It was kind of hard. Okay, so we're going to go between blood pressures of. Well, we want, what's the probability? Right here is our average. Our average is what? It's 80.8, and they want it between 70 and 90, so about 10 points either direction. It's not quite one standard deviation away, right? Because it's 10 divided by 10.2. It's not going to quite be one, but I'm expecting something around 68-ish, 66%. Okay, that's what we're going to see here. So 70, 90. Okay, so we want this probability right here. Okay, since it's between -1 and +1 standard deviations, more or less. Okay, we're going to say that's going to be about 68% from the empirical rule that we learned like so many chapters ago. Okay, so I want you to think about it that way too. They're going to ask you to do the actual calculation. That's what we're going to do. So distribution, we want the low number. So in this case, normal CDF. So we're going to say 70, comma, 90. And then what was our average? Or oops, I want 90. I want that. I just want 90. Comma. All right. No, it still doesn't like. I don't like it. Let's get rid of that. Delete. Comma. Okay. And then we had 80.8. And our standard deviation here was 10.2. I am not having a good day typing this stuff into the calculator. Okay, 80.8, just double checking, making sure all that stuff looks good. Seems pretty well here. You're going to be better at this than I am. Okay, 67.16%. Okay, so 0.6716. Okay, let's go down here. I just said it was 0.6716. That's close to 68%. Okay, that's not gonna be exact. That's okay. We don't care. Okay, 0.6716. Okay, so 0.6716. That's the 4 decimal places. So we'll go with that and we'll say check. Hooray, we got our probability. Yeah, I should have put the leading 0 in there. I didn't do it this time. Okay, a systolic pressure greater than 90 is classified as hypertension. I know that well. What is the proportion of women who have hypertension? So here we're going to go back to our same scenario. Okay, so we're still looking at an average, right? What was our average? It was 80.8, I believe. 80.8. Okay, and they want, what's the probability that somebody has higher than 90? Okay, here's 90, and I want all of this. Okay, I want this area that's here. So we're going to go to norm, CDF. Okay, my low value is 90. I need a high value. I need a value that is high when we are starting from 80.8 and we're taking steps of 10.2. Okay, so we could type in something ridiculous. We could type in 1,000. I think at that point, a person would explode. But we want 90 to a big number relative to this 80.8. Okay, so let's type in 1,000. Why not? Okay. Yes, it's ridiculous, but this goes off to positive infinity. Okay, so all of this is smaller and smaller and smaller and smaller. Okay, so the book is going to type in 1E99. That's 1 with 99 zeros next to it. We're just going to type in 1,000. We have 80.8, and then 10.2 is our standard deviation. Okay, so that's how we're going to do that. Okay, that's the proportion of women with that are going to have hypertension. Okay. So second function, distribution. Okay. And then we're going to have our low number, that was 90. Our high number, we'll type in 1,000. Okay. We just need something that's big relative to 80.8 with steps of 10. And I'm sure another number could have done it, but make it easy for yourself. Pick something easy to type in. Okay, 0.8. Okay, and then comma 10.2. And if you're with your friend and they typed in a slightly different big number, your values are going to be a little bit different. Okay, but not so much. We only go into 4 decimal places here. So 0.183. It looks like 0.1835. Okay, so this was 0.1835. Okay, and that's our probability there. Okay, so 0.1835. Right, check that. Right, hooray. And then, is it unusual for a woman to have a blood pressure lower than 62? So they're going to ask us why. So we're going to calculate that probability. Okay, so here we go. Okay, here's 62. Here's our 80.8. That's our average that we started with. Okay, so I want, what's a low blood pressure? I want some low number. So I want norm, CDF. We're going to go to low, high, mean, standard deviation. Okay, so we're going to type in norm, CDF. What's a low blood pressure considering that we have to go up to 62, but we have to take steps from 80 by 10s. Okay, I think 0 is a low number. All right, and then we're going to go to 62.5. Okay, that's what they asked for. That's our high number, so that's what we're going to check. Or just lower than 62. We don't have to do 0.5, sorry. Okay, so we just need 62. That's all we have to deal with. So we're just going to go up to 62. Okay, and then we'll have our 80.8 or 80 points. What's that? Double checking, make sure I type this in correctly, because if I didn't do that, that's going to be a problem. But back all the way up to the beginning here, 80.8 with 10.2, 80.8 and 10.2. Okay, so that's what we're going to type in to see what we have going on here. So distribution, okay, we want norm CDF, okay, and we want a low number, so we're just going to pick 0 up to 62. Okay, our average is 80.8, and our standard deviation was 10.2. Okay, hit enter. I think that's going to give me a wrong answer because of this comma here. I want point. Okay, nope, that was right. That was a comma. Okay, 80.8, 7.2. There we go. That should be okay then. Okay, enter. We got 0.0326. Okay, so we have 0.0327, because this 5 is going to push this 6 up by 1. Okay, we've already got 4 decimals. 1, 2, 3, 4. So I'll put the leading 0 there. That doesn't count, by the way. It's 0.0367, 327 rather. So that's what we're going to type in. So yes, it would be unusual because the cutoff for unusual is 0.05. Okay, so that's a nickel, right? And then here we're saying that we have like 3 cents. 3 cents is less than a nickel. Okay, so it is unusual because the probability of a woman having blood pressure lower than 62 is 0.03. So this is 0.0326. Okay, that's 7. I wish they didn't actually ask for all of the numbers, because that would be one more thing that we didn't have to do was wrong. But I've had this argument with this discussion with a lot of students. They ask a yes or no question, and then a lot of students will say yes. Like you're in college, you're not allowed to say yes. You have to say yes because. Okay, so 0.2027. Okay, so we'll check, or no because. Okay, and that's the answer they're going to want to give us. Okay, so that's not too bad. These are very common and you should expect problems like this. I would pick number 4 to put on a quiz in a second. Okay, it's a nice problem because it's got blood pressures. It asks everything that you would want to ask on a normal distribution problem, so everything is there. So this should be entirely expected when we get to the quiz for 7.4. Okay, so we'll continue, and I will see you in the next video. So please practice this, and we'll see you next time.